Hello, my name is Yao from Pong, and today I'm going to be presenting my final project, which is Twitter Vibes. Uh, so the problem that I wanted to solve is that social media can be a hostile environment. It can negatively affect people's mental health. So the goal of this project is to give users um, the ability to make analytical decisions on whether or not they want to follow a specific person or engage with them on Twitter based on a history of their previous tweets and whether those are positive or negative. Some of the challenges I faced was actually getting tweets from specific users. So I could use Twitter's API, but there's lots of limitations on that, like how much data you can get, and also a pretty rigorous developer account approval process. Or I could just scrape the data, make my own scraper with Selenium, or use an existing API like SNS Scrape, which I ended up using. The next task was like, how do I train my model to identify sentiment in tweets? I was able to find some data sets, a Kaggle data set called Sentiment 140. I ended up not going with this because it was just way too big and I didn't feel it was necessary to use all the data. Plus, I had to do a lot of cleaning up that data. And the other option was to mine my own data or label by hand. So I ended up finding a different data set, so about 30,000 that was already cleaned for me. Um, the next challenge was cleaning input data before trading. So you need to filter out things like emojis, links, hashtags, and Twitter handles, as these things will probably just confuse the deep learning model. And then finally, making a web app out of this, uh, so that I could like load in model weights that I already pre-trained. I looked into TensorFlow.js, or also just building in a web app using existing projects like Streamlit and WebPy. I ended up going with PyWeb.io, just because I didn't want to convert my code to JavaScript and deal with like having to convert models to TensorFlow. The motivation behind this work is that there's a lot of potential impact here. Twitter has 211 million daily active users, and one of the major challenges that they're facing, and they're trying to handle is like hate feeds, cyberbullying, misinformation, and how to do all those things at scale. A different approach would be, instead of Twitter trying to do everything, give users the tool to determine these things themselves. The paper I ended up using is called Adapting Sentiment Analysis for Tweets, linking to scientific papers. The dataset I ended up using is called Twit30K, which has 30,000 tweets and two labels, negative and positive. The related work I have, the first one is called Target Dependent Twitter Sentiment Classification. Pretty much what this paper, like how this is read, is that it does the same thing. It's exploring sentiment analysis of tweets by training a model on an existing Twitter sentiment dataset. The innovation they made in this paper is that they're using not just the actual tweet, but related tweets as well. So such as like tweets that reply to it to determine the sentiment of the target tweet. Since tweets can be short and big. And again, I chose this paper because it does something similar, but just makes an expansion on what I'm doing. The second related work that I did was on negativity negation. This paper explores like how to handle words like no, not, never, these negations in tweets for machine learning models, because it can confuse a machine learning model. You could have words like no, not, and never, and that's kind of associated with negativity, but it could actually be a positive tweet. So this paper talks about how to handle those edge cases, and that's why I chose it as another piece of related work. Pretty much the summary of the paper that I read was that the paper attempts to train a model, classify on positive, negative, and neutral. I ended up using a different data set, so just positive and negative for me. The innovation is that these tweets focus on scientific papers specifically, tweets that link to scientific papers, to give them an idea of like the overall sentiment around scientific papers on social media. So not just random tweets. They chose about 1,000 tweets to randomly analyze, and then again, similar to what I'll be doing, cleaning the input data to get rid of hashtags, Twitter handles, URLs. The only difference is that I'll be actually making the model from scratch myself. They'll be using an existing tool called SentiStrength to determine sentiment. My approach to building my tool is just use an existing dataset of 30,000 tweets, label positive and negative. They're already clean. I will have to implement my own cleaning function later on when I'm actually grabbing tweets from people's Twitter accounts because I need to clean those from emojis and stuff like that. Converting that text data to a numerical vector so that the model can handle the input. Splitting the data into a training set and testing set using 80-20 split. Using a linear support vector classification model to train and make predictions. Using the sklearn classification report method to evaluate my model's performance, and then saving the model weights so that I can use them later in my web app. So these are the results I got. That's not terrible for a model that I didn't fine tune at all. It's about 73 to 76% for precision, recall, and F1 score, and accuracy. The conclusion I got from working on this project is that real-time sentiment tweets is a feasible solution. And it has the potential to become much more accurate with more data and more fine-tuning. Some of the future work is actually hosting this web app in a public domain so that anyone can use it. Right now I'm just running it locally. Looking for more exhaustive data sets that contain more labels, such as like angry, annoying, sarcastic, and then making an API to move the function of the model inference. That way anyone could use my pre-trained model, and also I don't have to worry about, the model weights becoming too big and it becoming a problem when trying to host a website. User references. I'm just going to show you, the tool. So essentially, what I want to do is I want to get someone's tweets, their last, maybe 50 tweets. I'll get it from AOC. And then my model will then do inference on these tweets after cleaning out the emojis, and then determine if they're positive or negative. Again, like this is absolutely ludicrous, and the records can hold individual trace stocks. So this is deemed as like negative. So I'll get her last 50 tweets, and then the last 25 was positive, the last 26 was negative, so 51 tweets. So she's, I guess, neutral according to this model. I'll check another user. I'll use Elon Musk for this example. I'll get his last 40 tweets. Okay, a lot of negative, or maybe not. Let's see. So 31 positive, 10 negative, according to this model. So maybe he's someone you might want to follow, maybe not. But according to this model, he seems like a positive person based on his last 40 tweets. This is just kind of the code to build the actual classification model, loading the data, vectorizing it, splitting it, fitting the model, evaluating the model, and then doing inference. You won a prize, congratulations, that's positive. I hate pineapple pizza, it's so gross, that's negative. I got into Harvard, I'm so fun, that's positive. And then saving the model weights. And then in the code, this is a lot of the front end code, but essentially just taking the Twitter handle from the user input, and then attempting to get that tweet using the scraping API, and then doing inference using the pre-trained model weight after cleaning the input, and then returning the result to the user. Okay, I think that's everything. Thanks for watching, and if you have any questions, I guess we'll discuss them in the discussion.